Okay. So today we are going to start new subject. Uh, Not to make you stressed or something, but this subject is really new in India itself. If you will look on the Google, very few universities, even very few IITs are offering this. And the reason, thing is, this delayed our course also because there was no such material available, and I was searching to design the course in such a way that it could be useful for a computer engineer. Normally, the course or the material that is available are basically for physics person. Okay, so I have designed the syllabus in such a way that we can understand this subject, how it is different from the existing classical system that we are dealing with, the basic operation that you are doing using the classic system, how much operation can be moved, how we say that quantum system is going to change the era. It is going to give you a new era of computing, and yes, it is. You will be surprised that for enhancing the processing power, suppose your system is having 32-bit computer. Now to make it 64-bit, you need 32 extra bit for doing the storage, for doing the processing. But when you are doing the quantum computing, you just need to add only 1 bit to double the processing power. So this is what quantum is. So,
Ma'am,
uh,
are you presenting the screen?
no, I'm not presenting. I'm just giving you overview. Then I will be presenting it. I have not yet started, and I will not presenting it. I will write it. I will be writing it for you. Okay.
Okay.
Hmm. Just wait a minute. Hmm. Yeah, I was just giving you an introduction or a brief of the quantum what I will be covering. So I'm just sharing my screen. Okay. So I will first of all tell you what we are going to cover in this course. Mm, I will be giving you the book information. Normally, you could go for the books. One book is Quantum Computing for Everyone. Some portion I will be covering from this. This is from MIT Press. Uh, the author is Chris. mm this one. There is one more book of Philip and Introduction to Quantum Computing. But in these books, you need to do filtration. That means you cannot make them they as your textbook, and there is nothing like can say that this can be your textbook or the books. I will be giving you. I will be sending the group itself. What are the books we are going to follow? So books is not a thing. So what I will be covering, I will be just giving you a brief idea. See, in the first part, I will be discussing you what do we mean by quantum computing and how quantum computing differs from classical computing. or in a simple way, what is the thing that adds so much power to quantum? So normally, if you remember, in classical computing or in the system that we use, we store the information in the form of binary. The bit is either 0 or the bit is 1. While in quantum computing, the information is stored in a new bit pattern, that is qubit. So what is the difference, or what makes it difference? In binary or in the classical computing, when you are storing the information 0, you are sure that it is 0 or it is 1. Now you do decimal to binary conversion, binary wave spaces, we have designed the gates like that, all is working. But the quantum computing is based on the concept of superposition. Now what is it? Okay, see, when you spin a coin, either when the spinning end, the coin will be either in the 0, that is head, or tail. So the final output is your classical computing, what we store. We are neither bothered about what is the condition when it is spinning. But here comes quantum computing. Quantum computing, this qubit is having the information that when it is spinning, it's the spin condition is like qubit. When it is in spinning state, you cannot predict what will be the final output. The moment you predicted it, simply you ended in one of the output. Got it? So normally in quantum computing, this qubit is the superposition of both head and tail. That means I am in the probabilistic state. Classical, you are in a confirm that this is the final output. In quantum, you are not going to have anything that it is confirmed. Quantum is you are in a probabilistic state. It can be this also, it can be this also. So what's the meaning of this? It's simply a confusing thing, that then how we are going to deal with this. So let's come to your basic physics. I hope you all remember your 12th class physics. And it was proved that wave is having a dual nature. Or you can say the part wave light has dual nature. Light showed dual nature of wave
Ma'am,
and particle.
can you please join another link I have shared to you? Ma'am, actually, there are more students, more than 100, so.
Okay. That 100 students are in. So can we join? Let me think.
I have shared.
But that will be requiring my different mail ID, no?
I have shared you on the WhatsApp.
That you have shared in my WhatsApp, but the thing is, it will be requiring my another email ID.
No, ma'am, you can join it on this only.
Let's see. Why don't the student join on the Google Classroom link that we have created? Ask them to join there. That will be more easy for me.
Okay, from tomorrow.
I'm entering it. I'm entering it. Where's my mobile? Yes. Wait. I'm entering it. Today is the first day they are all joining. Then everyone will go. Okay. So I will just share my screen here also. Okay. So we were talking about what is quantum, actually how it is different. So just coming back, in the class 12 you have studied that light shows dual nature, wave nature and particle nature, and different phenomena was discovered, like interference and diffraction was discovered or showed the light wave property, while the photon hitting the detector and all showed the particle nature of light. Similarly, the same phenomena was applicable for electron also. And if you remember, I suppose de Broglie hypothesis only said this thing, and you are, I suppose, more aware, or you have just recently studied, you might be knowing that every particle, every particle shows dual nature, wave and particle nature. For the larger particles, the wavelength is very small, so we are not able to see the wave nature, we are just able to see the particle nature. Yes. So that concept was used for the electron, and that is the basis of your quantum computing. So electron shows both wave and particle nature. And if you remember, I suppose it not actually getting the name of the scientist. Simply, it says that you can. I suppose Heisenberg's uncertainty principle. What was that? If you measure the exact particle, you will not be able. It is to you will not be able to get the exact position. So anything will be unpredictable. I'm just. Do you anyone can tell me? What was that uncertainty principle? You cannot measure both of them simultaneously.
Uncertainty principle, it stated that you cannot measure the position and speed of a particle with exact precision at the same time.
Yes. So that is the basis of this quantum computing, because normally we are now dealing with where we cannot predict where the electron is going to be placed in the quantum. If we try to locate it, we will simply not be able to measure the velocity. So that was the basis of this equation. Okay, now the question comes, ma'am, how it is related? How we can say that it is related? I will just give you an idea, because that is all physics concepts and all. So quantum says, okay, now electron is having a wave nature. Electron can be in, if you say Niels Bohr principle, in the last orbit, the electron can be unpaired. Okay, so if they are in unpaired, they show magnetic deflection. So based on this magnetic deflection, now if out in our environment also there is magnetic field presence. So based on that, electron can be in any of the spinning movement, or electron can be in any of the orientation. Got it? So we can tell in classical computing or classical, we were just measuring in this orbit electron is present or electron is absent. That is why we were saying it as 0, 1. Now what we are doing in quantum, we are going in a very basic level. We are talking about where the electron is. And based on this, that means now we are measuring the electron spin direction. It is in up direction spinning, down direction. Is in this orbit or in that orbit. It is spinning in the clockwise, or it is spinning on the anti-clockwise. So you are doing this measurement. So that means now you are dealing with this minute level information of quantum electrons. So now you are storing. Just think, electron there or not there. Only only one, you have two information, that is your classical computer. Now what you are storing with the electron? You are not just storing electron up or there, you are storing electron is spinning upward, spinning downward. Electron is in ground state, electron is in excited state. Electron is in path 1, electron is going in path 2. Electron is moving in horizontal direction, or electron is moving in vertical direction. Got it? Electron is polarizing the light in which direction. So all this information is stored with one electron. Are you able to understand? Now just one electron and this level of information. Now this gives the power to quantum computers, because you are storing all this information with one electron. Got it? And this information is stored in the form of qubit. We'll be discussing how it is stored. Just I'm giving you an overview. Clear? Now, as uncertainty principle says, we cannot measure. Simply, there was an experiment done for this. What was that? A very interesting experiment. We call that as Schrödinger experiment. Who predicted this uncertainty? See, this first class, I am going to give you an idea of this subject. how much new this subject, which is different from the computer subject that you are currently studying. See, what it says, as you cannot measure the electron, why you can't measure? Simply, suppose we have a cat inside a closed box. We have placed a cat inside a closed box, and there is a radioactive decay going on. Got it? Now, that radioactive decay is going on, or we can say there is a radioactive decay. The moment the radioactive decay will trigger, or the suppose cat hit that trigger, it is possible the poisonous gas comes out and the cat dies. And possible the cat doesn't hit it and the cat is alive. So that means the position or the cat condition is cat can be dead, cat can be alive. Till what condition you cannot predict till you open the box. The moment you open the box, you will be in one of the situation, cat is alive or cat is dead. But till the box is not opened, you are unpredictable, you are in a condition, it has this much percentage chances of alive, it has this much percentage of dead. So this is a measure of uncertainty. Similarly, when we are having electron, got it, we cannot measure, we are just giving the probability, it might be revolving in the left direction, it might be revolving in the this thing, probability of this is this much and probability of this is this much. Got it? So we are storing the probability of different components in this. You are not able to predict it. The moment you predicted it, the moment you predicted it, it's done. Now you are coming to exact one of the output. Got it? How much you understood this thing? A very small saying by a scientist, Feynman. It says, if what is quantum mechanism is still debatable, but this scientist said a very interesting sentence, and this you will see in every book of quantum computing. If you are not confused by quantum physics, you haven't really understood. And it says nobody understand, but we know how to do quantum mechanics, or you can say quantum computing. So that was the concept I was telling to you. See, it's a different thing. Not like the existing computers you are dealing with 0 and 1. Now you are dealing with the probability that electron might be spinning this side, electron might be spinning that side, electron may be polarized, left polarized or right polarized. So we will be storing the information in this way, and from this stored information, you are doing the computing. You are not able to understand or relate it like classical computers, because at that position you are having exact information. Now here the information are in a probability form. Is it clear? So that is the difference in this, and that's why it makes new and a bit confusing. Got a rough small idea of what is it? Okay. Let's have a small idea we'll give you for classic and quantum. If you say both deal with macroscopic particle like electron, it is based on electromagnetic wave theory. It is based on Schrödinger wave equation. So this is okay. So what in this, the state of the system is defined by their position. We can define the state position particles by certainty. The future state can be predicted by certainty. First thing, states are stored by certainty. The state is 0, 1. We are also sure what will be the next state. So this is based on certain, we are confirmed. While in the quantum, we are deal with the probabilities. That means it gives probability of finding particle at various location in space based on hypothesis, de Broglie hypothesis about nature of matter, that particle show both that matter shows both particle and wave nature. So in a shorter form, if I summarize it, classical, you are setting the information is in the form of 0 and 1, while in the quantum, you are not sure what is the exact information. You are in the probabilistic that the electron, it can be in anywhere in the space, and you have the probability of finding it. Okay. Now, when you are storing something which is in a new form, definitely you require a new way of dealing with this. So first thing that you are going to study is how are we going to represent the data. Then you are going to discuss the different operation, how it is performed, how you do calculation. Definitely these gates will be different than the gates that you are using for your digital system. And then these are the basic, from this starting we will be covering this, we will be discussing different type of gates in this. Now as we discuss, quantum has a era of computing which is going to enhance, then we will be discussing in the course different quantum computing problems that are solved, quantum cryptography, how quantum is evolving in quantum, the different algorithm that we are that are being designed or using the quantum circuits. So this all we will be dealing, and IBM, the first computer, quantum computer that was designed by IBM, and I suppose that was in 2017. And it was 16 qubit. After they had this one, and I suppose Google has claimed for 32 qubit computer, and they are in the starting phase of this. Now you can understand how much important this subject, or how much because the research is going on. They have designed this much. They are doing the programming using these gates and all, but still it is like a new era of computing, a new subject for the research. Okay. How much have you got just a brief idea of how quantum is different from the classical one?
Yes, ma'am.
Yes, ma'am.
Good if you have understood, because this concept took 4 days for me to understand. That means it's a good one. Now I will just give you more idea about this thing. So quantum computing relies on quantum superposition. As I told you, now we are not sure that we are in 0 or 1. Quantum, it's like superposition. We are spinning a coin. The coin can be in head or tail. So simply say spinning coin position is quantum bit or qubit in a layman language. A qubit is spin coin position. I don't know. It can be head also. It can be tail also. So suppose In classical computers that we use, we have 2 bits 0 and 1. In quantum computing, we are doing the measurement. Suppose we are doing the measurement for the coin only. Coin can be in one of the two states, head or tail. For today's class, you can understand these are just a notation. We will be dealing it. Normally, these notation we call as ket notation. We will be dealing later on. But for today's, just understand that these are the notation in quantum. Now, these are basic states. It can be, but what actually in quantum computing, the system is not in one of the state, it is a superposition of the state. So normally the state is defined as combination of these two. So simply when the coin is spinning, it has some probability of having head, some probability of having tail. Got it? So this is actual a quantum bit containing information of both. Like when we are dealing with cat, we are just viewing the cat and we are just saying maybe the cat is dead, maybe the cat is alive. This alpha and beta, they are both complex numbers and we call them square of probability amplitude. We'll be discussing them in detail, but till now for the basic one, they satisfy this condition. Okay, so if we talk about in quantum computing, the power lies in the superposition. How? Just have an idea. I will give you an idea. Now suppose we have 4 qubits. If you are having 4 classical bits, what information you are storing? 0, 0, 0, 0, 0, 1, that is 0, 1 to 16. 4-bit, this information. Okay. Now, when we deal with quantum, this is your 0 state. And what is normally, if I define what is this state? It is the state. This is quantum basic state. So quantum basic state is 4-bit. This is just understand. This is an option. This is a normally we call it tensor product. We'll deal it later on. Just understand this is some operation. Something like this. Yes, any doubt? I'm just representing them. Similarly, you represented this classic. I'm just writing them in the same form. So this all are these are basic states of quantum. Now, superposition of these basic states.
What is this cross represent?
Cross is tensor product. We'll be studying it later on, how it is done. And just for now, understand it as this is an operator. Normally it is tensor product. For today's class, understand this as an operator. You are having 4, because see, you will be having some information, some operation is performed. So this is an operation. For the symbol, I have represented it in this form. Now, this is what? This is a qubit, which is a combination of all this basic state. Now, how it will be? It is A0 of first one, A1 with second, A2 with A2n minus 1, 15. Or if I generalize it, it is A0 this plus A1 A, there it was 15 only. Now it is A to n minus 1 to n minus 1. This is just 1 bit, 1 qubit. Now understand this thing. So for 4 qubits, you are having 4 basic qubits and 2n minus 1, sorry, or you can 4 minus 1 qubits, superposed qubits. I was having 4 bits. I generated 15 basic states, basic, not a combined. That means the electron because I am storing now 4 information. So these are the basic states. I have given 4 bases. I will be storing 4 information. Now this is psi, combination of this. Just see with this 4, you can have 15 coefficients. 15 can be changed by any numbers. That means you are able to store these many information taking only 4 bits. In classic computer, 4-bit means only 16 numbers. Now understand in this, that will be this many basic bits. Now, so 4 bit, just a minute. So when you are having n qubits, you can have 2 to the power n minus 1 superposed qubit states. You will be having these many coefficient, and these many coefficient can have any of the values. So superposed will have these many qubits information. Now suppose I will give you an example. Suppose I am just dealing with 300 electrons. That means 300 basic qubits. Now we could have 2 to the power 300 is equal to 10 to the power 90 complex coefficient. Only 300 electrons, not more. Just 300 electrons. So this much information can be stored. The existing storage capability in the world is this. Existing storage of world. And just with the help of 300 electron, you are able to store this much information. So the moment we are able to work on 300 qubit system, you can imagine the storage we are having, the power we are having. Total atoms in the universe are this. So 300 electrons are having more than this. Now just understand the number of electrons you are increasing, how much power of computation you are increasing. So this gives quantum computing immense power. That is the reason it is assumed that if we are able to do more processing, we are able to design more algorithms, we are able to do the problem which are still unsolvable. If you have heard about security, normally RSA was claimed to be secure, then it failed. The current AES, if you open your Gmails and all, the current encryption method that is used in AES 256, it is used. When this quantum is going to come, till now it is debatable that it will take 100 years to break the key, and a human being does not exist for 100 years, it is like that, it is assumed. But when the quantum will come in the array, it will just take seconds to break it. The whole algorithm can collapse. The COVID wigs, normally it has because what we do in the drugs and all, we have a molecular formula, we have to try all the combination. So if quantum was there, it is, if you see it, I was just reading somewhere, it was quoted that if quantum was in existence, the COVID vaccine was able to be discovered in just one day. It took months to discover. If it was quantum computing available to us, it would have taken just one day for the medical science to discover the vaccine. So this is the beauty of this quantum, that if it the thing only that is being creating a hurdle is we are dealing presently with the probability, and with this probability only it is very difficult for computation. So that is why we have to think in a different form. The existing circuits or existing thing we cannot think, because now what I'm saying, that we are going to see where the electron is spinning and where the electron is. If you remember, because these electrons are very tiny particle. Now suppose you predicted that electron is in 90-degree orientation. The moment there is a minute magnetic deflection, the orientation can change or your information can change. So that is why the computation, and this is a research or debatable topics going on, and still the research or a new beginning to be done, multiple aspects for you to further. So this, I have given you a brief idea. Now one more important thing. This you have gone the power. Now just with this, understand how much information you can store. One more thing. Now suppose, very simple, if I am dealing with just 2 qubit, that means 4 basic states. 4 basic state. So in that case, so I'm representing is this is my one state. Now, if I apply a function on this, I am able to apply the function on all of, because the function will apply to side, that means all the qubits. So the function will be applied on all this. So simply if I say, suppose this is 2 qubits, or I'm storing 4 information, and I apply a function. I apply a function of psi. Now what? I am applying the function on 4 basic qubits. So that means I am able to modify these 4 qubits in one operation. But if you do for the classic computer, when you are applying function, you are applying function for only one register. If you are reading one register. For other, you have to again load it, do the processing. What is in quantum computing? One operation, all modified. So it gives immense power in the field of quantum parallelism. As quantum mechanism is linear, so if we apply any operation to input, we can do operation in all basic qubit at once. Okay, so this is a basic idea I have given you why the subject is important and how the information is basically stored. We'll be dealing it how this notation 0 says, and in 0 what we are storing and how we are going to deal with the person. Just a basic overview I have given you so that you can understand how the representation is different from the existing system. Okay. So simply measurement in qubit. So if I write this, this is simply like the state of qubit, state of a qubit or in quantum is like a spinning coin that I am representing. If it was coin, I could have shown it is in a coin or rotating coin. It has alpha square probability and beta square in this. So this is the state of spinning coin, which has alpha square of probability that it will be in head, or beta square it will be. So what I represent it in this way. And this we call as probability amplitude, because sum of alpha plus beta is not 1. The condition is alpha square plus beta square is 1. So if I define this qubit is linear superposition of two states 0 and 1. Okay, now I want to Now, one more important thing. See, in quantum, we have three important concepts. One is superposition, second is entanglement, which gives its a power, and third one property is decoherence. Next property, I will just give you an idea. What is this? Entanglement. Entanglement, if I make you understand, this is such a property that makes us communicate with a speed faster than light. Help to communicate with a speed faster than light. Okay. Let's see how it is done. Now suppose we have two particles. Particle 1, the state is U1, which is a combination of or superpose, and similarly particle 2, it is linear, it is superposition of its two basic state. We are assuming this. Okay. So now suppose we define tensor product is just for presently assume that it is just like multiplication. I combine the state. That means now there are two particles. I am combining the information of them. Okay. So I'm just doing the multiplication. If I do the multiplication, it will be. Don't bother. We will just studying all this in a detail. How it is done. How the operation is done. Just to make you familiarize with this. How I have multiplied and all we will be discussing. I'm just writing it. Alpha 2, beta 1, B1, U2, alpha 2 beta 2. Okay. Now for u2 and v2, just I have done multiplication of these two. This is a superposition state. These two particles described by their states, that means these are their basic state. Now I'm combining both the particle information, like I'm assuming that one particle is on earth and the other particle is this, and suppose I combine their information. So this is a superposition state, or the combined state combining the information of this. Now let's have a look on this state. U1 Now, if I look to this state, it simply says if particle 1 is in U1 state, particle 2 will also be in V1 state. If particle 1 is in U2, particle 2 will be in V2 state. That means if my superposition state is only having this, either this or this, plus now it's or, either this or this. So in this manner, now just have a look. If first one particle is in U1, do you need to communicate or tell? Definitely it will say the particle will be in V1 state. What I want to say is, if superposition state is a combination of this, and these coefficient can be any of this, but suppose you are in any of this state. So what does this state says? It state says if particle 1 is in U1, particle 2 will be in V1 state. If particle 1 is in U2, particle 2 will be in the V2. That means they both are connected. And this is not equal to, this is not equal. The reason is, if I make them equal, just have a look. If I make them equal, what I require, if I make them equal, what is going to happen? It is going to happen that alpha 1 beta is equal, alpha 2 beta is equal to 1, alpha 1 beta 2 is 0, and alpha 2 beta 1 is equal to 0. Now see, for any two numbers to be 0, what we require? Either this is 0 or beta 2 is 0, beta 1 is 0, or alpha 1 is equal to 0 or beta 2 is equal to 0. Now just have a look. If any of this will be 0, this condition will not hold. Are you getting my point? So for these state, for these spatial state, super will be having a different look. That means these states are unfactorizable. These states cannot be represented in the form of this. Are you getting my point? For normal state, it's fixed. I don't know why the color is not changing. Okay, just have a look. When I'm saying for the normal state, this is my superposition state. But for when this is the spatial state, that means particle was in U1, this cannot be generated by this because this requires this condition to be satisfied. So we can say this spatial state is called as entangled state. This state is unfactorizable. In this we cannot describe, in this state, it cannot be described by telling what particle 1 is doing, what particle is doing. This state is just a fix. That means it gives a simple information that if the particle 1 is in U1 direction or U1 state, particle 2 will be in V1 only. If particle 1 is in U2, definitely particle 2 will be in V2. So suppose assume it that one particle is on Earth and the other particle is on Pluto. If the particle on Earth is on U1 state, there is no need of communication. Simply you can say the Pluto particle will be in the V1 state. So that is entangled state. So in quantum computing, we are having some set of the states which we call as entangled state. So when the system is in one state, without sending the information, you can predict other particle state. Now just understand how have you communicated the information? Without communicating, the information is communicated, so information is transmitted in greater than the speed of light. So this has huge applicability in quantum cryptography where you need to exchange key. So now just with the help of this state, so we will be discussing it how, because how this saves this is not compromised because we are having some specific sets. Then also the attacker is not able to find it out. That we will be discussing this. Just I have to give you an idea of this entanglement. Oh, class is just I will be just giving you just a brief of this last property, decoherence. Decoherence says we are assuming we were in this condition for the spin one. We are saying the coin is spinning, head and tail. The moment the coin put down, either in head or in tail. So the moment you collapse to one of the state, in that case, the information is lost. So now you can understand that moment you are in one of the state, the quantum, that moment it is just the state is gone, information is lost. And the current era of magnetic and all, the electron and spin direction changes very frequently. That is the reason the quantum states are a fragile state. The computing is a bit challenging for current era and research point. So yes, please. So I just because this is a new subject, I'm not idea. Just I've given you an overview. So tomorrow I will be going with the bit by bit detailing of everything. Now I just it is just a 2 minutes. I will be asking you: are you able to understand what is quantum computing in this? Because this is a new subject, I require your feedback for this. Because I'm working immensely hard for this subject. Nothing I'm finding on anywhere, on the net or anywhere. Are you able to understand the basic idea of quantum computing in today's class?
Yes, ma'am.
Yes, ma'am. At some point.
Yeah, it's a basic a tough subject. And one more thing, the topic you find it difficult, it will be very nice if you revert back to me on the email ID or mail ID. I suppose the group I have created. That's the reason. You can write it. I can repeat the topic, or I can give you more easy concept to understand that topic. That was the reason. So I will be sharing my notes for this because the books is next to impossible for you to find it out. So I'm making some notes and I will be sharing the notes for you. That will be ease for you. You cannot study with books. This I have seen. Okay. And planning to have one midterm and one end term will be there. Quizzes or assignment, I have not thought much. Maybe I will be giving you one assignment and one quiz. Okay? So this will be our evaluation on all this pattern.
Will the quiz date be announced beforehand?
I will. No surprise quiz, nothing. This subject is new. I will not give you more surprises. The subject is itself a surprise. Okay?
Okay, ma'am.
Okay. So you can leave the class.
Ma'am, you can share the email ID. Me, I will share it with the students.
You just I will just write it, or you can. I'm writing it on the message. You can just have a
You
look.
can write it here only.
Here only I'm writing it because I will be writing the triple IT quota ID only. I will be sharing you both the preferred this ID because visiting underscore. I'm sharing my both ID with you. Prefer that quota one because that I will be using only for you students. This is my institute ID. Okay. Yes. Okay, students. So we'll meet day after tomorrow, not tomorrow. Day after tomorrow on the same time.
Okay.
And on Friday. Because tomorrow is a bit hectic day for me in the college.
Okay.
Okay.
सूरज चंबल के खोले मन बोले दिया एक सेकेंड रिकॉर्डिंग ऑन कर लो